68.9%. That is China's share of global EV battery installations in 2025. Not a majority, a supermajority. And CATL alone holds 38% of the entire global market. Welcome to Asia Tech Macro. I'm Alex.
And I'm Maya. Today, we're diving into the EV battery supply chain because two developments in the past 8 weeks are reshaping the competitive map in ways that every investor in Asian industrials needs to understand. First, CATL confirmed at its December 28th supplier conference that sodium-ion batteries will deploy at commercial scale across vehicles and energy storage in 2026. Second, Toyota has quietly moved its solid-state battery timeline forward, targeting small-scale mass production imminently. These are not incremental updates. They represent a potential chemistry inflection point for the entire industry.
Let's set the foundation with the market data. According to SNE Research, global EV battery installations reached 933.5 gigawatt-hours from January to October 2025, a 35.2% year-on-year increase. Chinese manufacturers collectively hit 644.4 gigawatt-hours, controlling 68.9% of that volume. CATL led with 38% global share, BYD second at 16.9%. South Korean players are losing ground. LG Energy Solution fell from 11.1% to 9.3% market share, despite growing absolute volume. SK On holds just 4%. Japan's Panasonic, once Tesla's exclusive partner, is further marginalized.
And the sodium-ion story is the one I find most fascinating right now. CATL confirmed at its Ningde supplier conference on December 28th that its next-generation sodium-ion battery achieves 175 watt-hours per kilogram energy density, supports over 500 kilometers of driving range, and has passed China's new national safety standard, GB 38031-2025, becoming the first sodium-ion battery to achieve that certification. Large-scale supply begins in line with customer rollout schedules in 2026. An AlphaSense battery consultant noted that CATL's second-generation sodium-ion cells will reach commercial scale 2 to 3 years sooner than the industry expected.
And the strategic logic is compelling. Sodium-ion batteries use no lithium, no cobalt, no nickel. The raw material is essentially salt. For a company that has built its empire on lithium-ion chemistry and therefore has exposure to lithium price volatility and geopolitical mineral risk, sodium-ion is a genuine hedge. CATL's co-chairman Pan Jian framed it precisely at Davos in January. If one mineral gets expensive, the market shifts chemistry. Sodium-ion is CATL positioning to lead that shift rather than be disrupted by it.
Meanwhile, Toyota is betting in the opposite direction: higher performance, higher complexity. Small-scale solid-state battery mass production is the target, with BMW announcing a prototype vehicle equipped with solid-state batteries in 2026. China's government launched a 6 billion yuan national stimulus specifically for solid-state battery R&D, with CATL receiving first batch support. Every major chemistry is moving simultaneously. In Part 2, we dig into what that means for Korea and Japan. Stay with us.
Okay, segment 2. Let's talk about the Korean and Japanese response, because the market share numbers I cited in Part 1 are not just statistics. They represent a structural erosion that has direct consequences for Samsung SDI, LG Energy Solution, SK On, and Panasonic. Maya, what's the honest assessment of where Korea stands?
The honest assessment is Korea is in a serious squeeze. On the low end, CATL sodium-ion push threatens to commoditize the entry-level and mid-range EV battery segment, where Korean manufacturers have been trying to compete on cost. On the high end, solid-state batteries, where Korea has been investing heavily, are taking longer to commercialize than hoped. LG Energy Solution's latest investor presentation in January 2026 pushed its solid-state timeline to 2030 for volume production. SK On is in active financial restructuring after posting consecutive quarterly losses. The gap between CATL's execution speed and Korea's is widening, not narrowing.
And the numbers confirm it. LG Energy Solutions' global market share dropped 1.8 percentage points in 10 months, despite the overall market growing 35%. That means they're losing share in an expanding market, which is the worst possible combination. Samsung SDI is the relative bright spot, holding share in the premium segment through its partnership with BMW and Stellantis. But Samsung SDI's total volume is small relative to CATL, roughly 4.9% global share.
Okay, devil's advocate though. Korea's battery makers have one structural advantage that CATL cannot easily replicate: U.S. IRA compliance. The Inflation Reduction Act's domestic content requirements effectively create a protected market for batteries manufactured in North America by non-Chinese companies. LG Energy Solutions' joint ventures with GM in Ohio and Michigan, SK On's partnership with Ford in Tennessee and Kentucky. These facilities are CATL-proof by regulatory design.
That's the bull case for Korean battery makers, and it's real. But here's the complication. The IRA's future is uncertain under the current U.S. administration. Multiple provisions are under review. If the domestic content requirements are weakened or the EV tax credit structure changes, the regulatory moat that Korean companies are depending on narrows significantly. They're building a business model around a policy that may not be stable.
Which brings us to Japan and Toyota specifically. Segment 3, the ripple effect. Because Toyota's solid-state bet is not just a product decision. It's a strategic wager that the current lithium-ion paradigm has a ceiling, and that the company willing to invest most aggressively in the next chemistry will define the next automotive era.
Toyota has been working on solid-state batteries longer than any other automaker, over a decade of R&D with Panasonic through their joint venture Primearth. The current target? Small-scale mass production of solid-state batteries in the near term, with broader deployment by 2027 to 2028. The claim specifications are extraordinary: double the energy density of current lithium-ion, 10-minute fast charging, and significantly improved safety from non-flammable solid electrolyte.
And China is not standing still. The 6 billion yuan government stimulus for solid-state R&D launched in January 2026, with CATL, BYD, and SWALT all receiving first-batch funding. CATL Robin Zhang stated at the Davos World Economic Forum that CATL will have solid-state batteries in commercial vehicles by 2027. So the race is Toyota with a 10-year head start in solid-state IP versus CATL with vastly more capital, government support, and manufacturing scale. That is a genuinely uncertain contest.
And the ripple to mining companies is significant. Sodium-ion's commercial scale removes lithium demand from a segment of the market. Solid-state batteries at scale would dramatically increase lithium demand for the high-performance segment while potentially reducing cobalt and nickel exposure. The commodity implications are enormous, and they're moving in opposite directions simultaneously, which creates real confusion for lithium miners and battery materials companies trying to plan capital expenditure. In Part 3, I have a contrarian view on who actually wins this chemistry race. Don't go anywhere.
All right, contrarian corner. And my view today is this. The entire battery technology race narrative, sodium-ion versus solid-state versus next-generation lithium-ion, is a distraction from the variable that actually determines who wins the EV battery market. And that variable is manufacturing yield rate, not chemistry.
Yield rate, not energy density or charging speed.
Yield rate. Here's the argument. Every chemistry breakthrough announced by any company, CATL, Toyota, Samsung SDI, eventually has to be manufactured at gigawatt-hour scale with consistent quality and acceptable defect rates. That transition from lab performance to factory performance is where battery companies succeed or fail. And CATL's single most underappreciated competitive advantage is not its chemistry, it's its manufacturing process control. CATL currently runs yield rates above 95% at its Ningde gigafactories. That number represents 15 years of iterative process improvement, proprietary equipment calibration, and institutional knowledge that cannot be replicated by writing a check.
So the contrarian implication is, even if Toyota's solid-state chemistry is genuinely superior, the manufacturing learning curve gives CATL years of runway to respond.
Exactly, and history supports this. When TSMC moved to advanced nodes, competitors had access to the same ASML EUV machines, the same materials, the same basic process knowledge. The gap came down to process control and yield optimization, which is accumulated institutional knowledge, not purchasable technology. CATL's manufacturing advantage in batteries is structurally analogous to TSMC's process advantage in semiconductors. You can license the chemistry, you cannot license 15 years of yield improvement.
That's a sharp analogy, but isn't there a counterexample? BYD built competitive manufacturing capabilities significantly faster than most analysts expected. If BYD can do it domestically, why can't Toyota or LG Energy Solution close the gap?
BYD is actually the exception that proves the rule. BYD closed the gap because it had two things: massive domestic Chinese market scale to absorb early production inefficiencies, and vertical integration from raw materials to finished vehicle that gave it unique feedback loops. Toyota has the scale, but not the vertical integration. LG Energy Solution has neither at CATL's level. The companies best positioned to challenge CATL's manufacturing moat are Chinese, not Korean or Japanese, because they operate in the same ecosystem with similar supply chain access and similar government support structures.
So the bear case for Korean and Japanese battery makers is more structural than cyclical. It's not that they're having a bad year, it's that the manufacturing gap may be genuinely difficult to close regardless of chemistry innovation.
Precisely. And here's my question for our listeners. We've established that CATL's manufacturing moat is real and deep. We've established that solid-state batteries could be a chemistry reset that levels the playing field, but only if Toyota or another non-Chinese player can actually manufacture them at scale before CATL does. The question is, what is the probability that solid-state battery manufacturing at gigawatt-hour scale outside China is achieved before CATL deploys its own solid-state product? Because that probability, whether you put it at 20% or 60%, completely determines your investment allocation between Toyota, LG Energy Solution, and CATL. And I don't think most investors have thought carefully enough about that specific question. It deserves a precise answer, not a narrative.
That is exactly the right question to force precision on. Part 4 has our answer. Stay with us.
All right, action items. 3 concrete things to do with everything we discussed today.
Number 1, separate your battery investment thesis by time horizon before allocating. In the 0 to 3 year window, CATL's manufacturing moat and sodium-ion commercial rollout make it the highest conviction play in the battery space. The stock trades at approximately 22 times forward earnings on the Hong Kong Exchange, a significant discount to its 5-year average, partly because of Western investor geopolitical hesitancy that may be overcorrected. In the 3 to 7 year window, the solid-state question becomes live. If you believe Toyota's manufacturing timeline is credible, Toyota Industries and Panasonic Holdings become asymmetric bets on a chemistry reset. Those are not the same investment. Size them differently and don't conflate the theses.
Number 2, treat LG Energy Solution and SK On as IRA-dependent businesses, not global competitors. The Korean battery maker's investable thesis in 2026 is almost entirely about U.S. market access through IRA compliance, their joint ventures with GM, Ford, and Stellantis. That's a real and valuable position, but it is a regulated market story, not a technology leadership story, which means the primary risk to monitor is U.S. energy policy, not battery chemistry. Watch congressional IRA amendment debates and Treasury Department guidance on domestic content requirements as your primary catalyst calendar for Korean battery stocks. If IRA protections hold, the thesis holds. If they erode, the thesis erodes with them, regardless of what happens with solid-state timelines.
Number 3, add battery materials companies as a lower risk complement with asymmetric upside. The chemistry uncertainty we discussed, sodium-ion versus solid-state versus next-generation lithium-ion moving simultaneously, creates real confusion for commodity investors. But one materials category benefits from almost every scenario: electrolyte and separator manufacturers. Whether the winning chemistry is sodium-ion, solid-state, or advanced lithium-ion, every battery needs high-performance separators and electrolytes. Asahi Kasei and Toray Industries in Japan, Celgard in the US, and Yunnan Energy New Material in China are the picks and shovels layer of the battery chemistry race. They get paid regardless of which chemistry wins.
The takeaway for today: the EV battery industry in 2026 is running 3 chemistry experiments simultaneously: sodium-ion at commercial scale, solid-state approaching small volume production, and next-generation lithium-ion still improving. CATL's manufacturing moat means it leads in all 3 races today. But solid-state is the genuine wildcard, the one chemistry where Toyota's decade of IP investment could matter more than CATL's scale advantage, if Toyota can solve the manufacturing problem before CATL does. That if is the most important variable in Asian industrial investing right now.
And the meta lesson: in deep technology industries, the company that manufactures best usually beats the company that invents best. Chemistry is the story. Manufacturing yield is the scorecard.
Next time on Asia Tech Macro, we're looking at Southeast Asia's cloud and data center boom. Singapore is hitting capacity limits. Malaysia and Thailand are the next battlegrounds. And hyperscalers are making billion-dollar bets on infrastructure that won't be ready for 3 years. How do you invest ahead of that build-out? That's next.
The infrastructure story keeps getting bigger. Really looking forward to that one.
Stay data-pregnant. Bye.